Hi, good afternoon. Well, good morning here in Australia. G'day. Thanks for joining us to this session. It's called Developing Windows 8 Applications. It's part of the Microsoft MVP Mentor Program. Please allow me to introduce myself. My name is Angel. I know it's spelled Angel, but it's pronounced a bit differently. It's Angel Hernandez. I'm Microsoft Visual C++ MVP. And I've been an MVP since 2006, and I'm very happy to be part of this program to help communities and just to share the knowledge, because when one shares the knowledge, we learn at the same time. So I was expecting to get to see more people today, but it's a good thing that we're going to record this session, so it will be available for download a bit later. So okay, cool. I'm gonna start by just going to the agenda. So Windows 8 comprises a lot of stuff. I'm not going to cover all of them, mainly because of time constraints and limitations. However, I was able to compile and break down this presentation into 4 different areas. I would like to walk you through Windows 8.x. I call it Windows 8.x because at this moment in time, we got Microsoft Windows 8.1 was released, and then back in April last month at Build, Microsoft announced the general availability of the update 1. So I'm going to refer to Windows as Windows.x. Okay, so I'm going to walk you through the new changes in the operating system, as well as I will walk you through, and I'm going to talk to you about WinRT, about what WinRT is, what's the architecture, what is language projections, and whether you want to believe it or not, whether it's COM-based. And then I'm going to walk you through XAML, and we'll finish off by talking about asynchronous programming in Windows 8. I put together a couple of demo applications, and I'll walk you through those as well. So let's get started. So what's Windows 8? So here we can get to see the genealogy of the operating system since the first release. The first release was back in 1985, if I'm not mistaken. It wasn't that very commercial. It wasn't a hit, but that laid the foundations for the operating system that we know and love today. So that was just an extension to MS-DOS, to the operating system, and it was pretty nifty what Microsoft was able to put together and build at that time, taking into consideration the constraints and limitation we had in hardware and CPU processing. Then Microsoft made it release version 3.1, 3.11, which was the workstation version. And then something very cool happened. Microsoft introduced Windows NT. The beauty of Windows NT is that some of the core functionalities and features that we can find in the operating system today, they were introduced back in Windows NT. Good example is, IaaS, or Internet Information Services, and or even COM+ or MTS, the Microsoft Transaction Server, and some of those features. A few developers today, they don't use it. However, they're still available, and they work fine. After that, that was the first 32-bit operating system not reliant on DOS. That was a leap ahead of the operating system we had at that time. So then Microsoft changed the paradigm once again. They introduced Windows codenamed Chicago, or 95, back in August 95. And however, it was still dependent. It was like an extension to the operating system, to the DOS, and it was 16-bit. But the changes were happening and occurring, so that took us to 2000, right? Windows 2000 was based on NT technology. And NT stands for New Technology. It introduced a new file system. So we were talking about being able the operating system being able to processing and handling much larger volumes in hard disks. So, for instance, in the old days, we had FAT16 as the file system. Then after Microsoft introduced 95, FAT32 became available, and FAT32 allowed users to create file names, to have file names up to 256 characters, and then NTFS was introduced with NT, but that was part of the 2000, right? So 2000 came in two flavors, the server and the workstation. At the same time, before I move on, Microsoft introduced a new technology called plug and play, which allows virtually to connect any device to your operating system, and the operating system is smart enough to recognize it and use it just by installing the right drivers. So then we had Windows XP, the one that we love and we learned to love, and we can get to see in use these days. And that was Microsoft once again changed the UI. However, the foundations plug and play was greatly improved because NT systems, they didn't play nicely with plug and play. The technology was at the very early stages, but XP became a solid, very commercial successful operating system. And at the same time, Microsoft introduced a new UI or UX, user experience. And it's a shame, but XP has reached the warranty for XP has reached its end. So it was, I think, if I'm not mistaken, until last month. But anyways, we can still see XP-based computers around. So that took us to Windows Server 2003, Windows Vista, which introduced a few changes around the look and feel and the security aspects of the operating systems. And then Microsoft made it to 2008, Windows 7, 2000 R2, and Windows 8. This slide deck, it's a bit verbose, and now it's got a bit of text in it, but the whole idea is just to give you a walkthrough about how the operating system has evolved throughout the years. So from humble beginnings, like Windows 1.x running on top of of DOS, to be a standalone, successful, stable operating system, to me, that's something which deserves some credit. So anyways, back to the Presso. So that covers pretty much the genealogy. I didn't cover or mention any improvement or fixes that were introduced with service packs or anything like that. This is just talking about the core, the RTM version of the operating system. Okay, let's move on. So Windows 8. What is it? I mean, I know that Microsoft reused, and it was built on the solid foundations of Windows 7. But what's the goal? What's the objective? Why Microsoft wanted to change the UI from 7 to 8? And the answer is very simple. It's a unified operating system for computers, tablets, and smartphones, right? So, until Windows 7, the operating system was capable of running Intel architecture, whether it was x86 or x64. I'm not going to mention Itanium here, but it was all around Intel. What happens is Windows 8, and let's call it 8.x, was the first operating system capable of running on ARM processors. And ARM stands for Advanced RISC Machine 32-bit RISC processor. And why Microsoft wanted to do such a thing? And the answer is very simple. Now, this world, we just can't help it. It's gone mobile. We're living now in a mobile era. It's the mobile age, right? And most of the chip that you can find on any mobile or handheld device is an ARM chip. Therefore, Microsoft, they have to make changes to the kernel of the operating system to support that transition, to support a different architecture. Back to the slide, Windows 8 also comes in two flavors or two versions. You got the workstation, which is the one that you get to see on your mobile or on your laptop or or your workstation, and then you also have the server version of the operating system. So what's the buzz, or what's radical? What's one of the radical changes that we can find in the new OS? Well, first of all, Microsoft they borrowed something from Windows Phone 7, which is the new desktop experience, right? Now, formerly known as Metro, and I'm going to refer to this new UI as fully immersive, because Metro, it seems to be that was a copyright by the time the technology was announced, and there were some issues there. So the Metro word or term has been deprecated. It's not longer in use. Now we are going to refer to this new UI as fully modern immersive UI. So it's fully immersive. Like I said before, it originally appeared on Windows Phone 7, and the beauty of it is that it provides an easy to use interface for touchscreens and such as tablets and smartphones. At the same time, the operating system also comes with two different versions of IE, of Internet Explorer. One of them is fully immersive, and the other one is similar to the one that you currently have on your laptop or your desktop. Cool. So back to the change of paradigm. Why the new UI versus the traditional UI? What are the main differences? Well, first of all, the traditional ones are windowed. You have your title bar, your maximize and minimize button, and the new ones, they didn't have it until Windows 8.1 release update 1, which I'm gonna show you later. And the traditional applications, they usually live and exist within the legacy desktop, but the new immersive applications have their own display space. They take out the whole desktop. And the operating system now, it doesn't rely on Win30, on GDI for the rendering. It relies a bit more heavily on DirectX, which is low-level API for high performance graphics, and it leverages the graphics card installed on your computer. And all applications, whether it's a traditional UI or it's a new UI, they participate in the application rotation. Let's suppose you can switch between tasks just by pressing Alt-Tab and Windows-Tab. And the new immersive applications, they have something similar to an icon, but it's not an icon as such. It's a tile. And the cool thing about having tiles is that it allows you to have dynamic content, which can be pulling information from the internet, for example. Cool. Now, I just covered pretty much some of the features in the client or the workstation version of the operating system. Now, I'm going to walk you through some of the major changes that have occurred to the server version of the operating system. The server version of the operating system is called Windows Server 2012. It's got a similar user interface to the workstation, the one that I just mentioned and described earlier. It's got a new server manager. From there, you can manage your servers, and you can add and remove features or roles from the server. It also introduces a new file system, which is called Resilient File System, or REFS. By the way, as you can see, there's a link there. What I'll do, I'll upload this presentation as well as the source code to my blog. I'm going to send it to Carrie, so you can share, you can download it later. So back to the Presso, it also provides support for something called Windows Azure Backup. And it's also got bits and pieces of the new UI. There's also a new feature called Cluster Aware Updating, which allows you to easily upgrade or update your nodes in a cluster environment just without going offline, which is pretty nifty. You also have SMB encryption, NIC teaming, or NIC teaming, and Microsoft has also made improvement and major changes to Hyper-V, which is the hypervisor, which allows you to run virtual machines on Windows. Cool. So now I'm going to share my desktop, and I'm going to walk you through some of those changes that has occurred or that were made to the operating system. Please bear with me for a second. Let me just share my desktop here. Okay. I guess that you're seeing what I'm seeing. Okay. So what I got here, this is the new UI. That's my daughter wearing some sunnies. And this is what it used to be known as Metro. As you can see, I'm running Windows 8.1 Update 1. Reason being is that you can get to see that I now got the power buttons here. I can, put my computer to sleep, or I can shut it down, or I just can restart it from here. The search has got a search button here, and they have made major changes. Also, you got this thing here that applications are grouped in a better way. And but one of the major changes was the start menu, the start button. Microsoft, when they released Windows 8, they took it out, but they listened to people's feedback, and they decided to put it back in. So the new Windows 8.1 Update 1 will allow you to, is smart enough to determine and detect whether you are running on a tablet or you have are running on a laptop or a computer. Therefore, now this is a start menu here. From here, you can get back to the start menu. But the important bit is that when you boot your computer, and when you start your computer, the operating system will take you to the desktop, so you don't have to do it yourself just by clicking desktop here, right? So as you can see, I got a few applications. What I'll do, I'm gonna start, the weather here. As you can see, and like I mentioned before, they are fully immersive. They take up the whole screen. But now, after when Microsoft released the update 1 for Windows 8.1, now you can get to see that there's like the title bar lights up and it hides, and I can minimize or maximize the window. But more importantly, I can also ping. They also show up on the taskbar, which that wasn't the case before. Right, there's something else here that I would like to show you, and it's the new Task Manager. Now this is Process Explorer. I like Process Explorer better than the one that comes out of the box. But what I'll do, I'm gonna revert back to the default one. Open it, and this is what you get to see, right? So you get to see this appealing, modern UI. This is all pretty much based on XAML, which I'll cover next. But yeah, this is the new Task Manager. You can get to see, the performance, or you can get to see pretty much what you see. You have two views, the more details and the fewer details as well. But yeah, this is the new Task Manager. Microsoft has also made changes to some of the desktop applications. So for instance, now, if we get to see, we can see here on my Explorer window, now you got a ribbon, and some of the previous applications or existing applications, like for instance MS Paint, they also have a ribbon. So you can, the UI has been refreshed, has been revamped, and they look much better than the old ones. And let me go back to the application. You can also snap your view here. Let's suppose that you can have it side by side, and let me just go back to my desktop. I can have a full immersive app running side by side of a desktop application on full immersive, and it's all there, right? So yeah, I mean, this covers pretty much this demo. It's just to give you a bit of taste or an idea about the few changes that there's been in Windows 8.1 Update 1. So let me just go back to the Presso, and let's keep presenting. Please bear with me for a second. Here it is. Let me just, oh no, wrong window. So PowerPoint. Back to the Presso. Oh no, hang on. No, developing. Yeah, here it is. It's loading. Okay, awesome. So that was the first demo. Now, some of you might be wondering, hey, well, this was supposed to be a talk around development, but I haven't seen any development yet. And the next slide is going to start, I'll start talking and walking you through WinRT. In order to understand how the operating system works, it's good to know, to learn the basics and then to enter and delve into the details. So now, WinRT. What's WinRT? So here we can get to see the Windows 8 platform. As you can see, you got desktop applications. Desktop applications, starting from Windows 8, you can build them using HTML and JavaScript, or you can build them using C and C++ or C# and Visual Basic. The idea is the developer, they can choose, right? Developers can choose the tool set that works best for them. So, and the beauty is, regardless of the tool they choose to use or they pick to use, they want to use, whatever is compiled and is built, is generated, is native code. And that's the whole beauty of WinRT. So WinRT is a new programming model that has been introduced with the operating system, right? So you can get to see here that, for instance, you got your APIs for communication and data. You got graphics and media, devices and printing, and you also have application model. As you can see, they sit on top of the Windows Core OS services. And this is important to notice. WinRT, and to make clear, WinRT is not a replacement for Win32. It's not. It's just a layer which sits on top of Win32, which is the Windows API. What happens is the developers, they don't have to write code or make calls directly to Win32. They do it through WinRT, right? And regardless, no matter if the developer writes code using C# or VB.NET, what gets compiled is a WinRT assembly. It's native code. All the code that's generated is native. Some people might ask, well, I just didn't get it. Why native and why not managed code? Reason being is, remember that this OS targets 3 different platforms, tablets or smartphones or workstations, right? Since we're going mobile, and that's a fact that we just cannot ignore, this battery life or handheld devices, they are always a tricky feature and thing that we have to take into account when buying a new device. Managed code is less efficient than native code in terms of power and in terms of performance. So that's why Microsoft decided to say, well, since we're going to target different devices, we're going to find a common lingua or a standard to make this happen. That's why everything that you built and develop using Windows 8 or WinRT is native. And the reason being is, performance, to have better battery life, and that summarizes the rationale, or that's the rationale behind their decision. So back to this, right? If you decide to build applications, you can either use C, C++, and C# and Visual Basic, but you're going to use for the UI aspect of your application XAML, which I will cover next. But if you're a JavaScript developer, HTML5 developer, you can still leverage and build this by, using the tools that you know. And there's this guy, Chakra, JavaScript Chakra. Chakra is the code name for the engine responsible for processing and running these HTML, JavaScript applications on Windows. Okay, let's move on. So back to the WinRT. What is WinRT? Well, it's a platform, homogeneous platform for application architecture. It supports both architectures, x86 and ARM. Like I said at the very beginning, or on my previous slide, it does not replace Win32. It does not. So some people, they think that it does, but no, it does not replace it. So it's implemented in C++, and it's an object-oriented by design, unlike Win32. Win32, most of the code that you are going to find the Win32 API is C code, but now, from a few years ago onwards, it's being, C++ a bit more. You're going to still find C code there, but C++, the new development, they've been written in C++. So applications, they run in a sandboxed environment for greater security and stability. Therefore, an application, a full immersive application, will not cause your system to crash. Let's put it that way. And it's always synchronous. Here, you don't have the concept of working synchronously. Everything is asynchronous. That's why C# has introduced a couple of new keywords, async and await. And in C++, you got the task class, which is a template class, and you also got the dem method within that class. What also WinRT does is that it provides services like metadata in a unified type system. That's why you can have, you can write code, you can have a model or an object, a class declared in JavaScript, and that guy or that object can also be reused from C++ or C#. I've written the next demo. I'll walk you through a similar situation. It's C# code interacting with C++ code. So let's keep going. So there's something else that's important to understand and to be aware of, and it's language projections, right? What is a language projection? Here we have this green box here called Windows metadata. That guy is the guy responsible for the projections, because as you can see here, you got a few boxes. You got your C++ application, you got your C# or Visual Basic application, which talks or interacts with CLR, and you also got HTML, which interact with the JavaScript engine. All these guys, no matter which technology or language you choose, it projects using the Windows metadata, and that is interpreted and processed by the Windows runtime. Okay, so the thing is here, as you can see, the C++ thing doesn't have any layer because this is all native. However, .NET, they have a layer, which is the CLR, the Common Language Runtime, and then is the CLR responsible for projecting that code into the WinRT runtime, and similarly to Chakra. So what is a projection after all? Well, a projection is the way that the Windows runtime APIs are exposed in each language. Therefore, if I have that's which really makes the unified type system. Let's put it that way. If you declare a variable in JavaScript as an integer or something, or C#, that guy will project as an integer, and it will be interpreted by WinRT as an integer. That's why you can get to see this unification of data types. And what is metadata? The metadata is pretty much describes the code that has been written in WinRT. The WinRT borrows the same .NET metadata format, and it contains definitions but not code. And I'm going to show you with the next demo how this whole thing works. Cool. Like I mentioned at the very early stages of this talk, I said that WinRT is COM-based. But really, is it COM? Yes, it is. COM, if you're not aware about the acronym, COM stands for Component Object Model, and it's one of those architectures and technologies which that was ahead of its time when it was released, and it was aiming to facilitate the development of components that could be later reused from different technologies. A good example, the operation Word. If you have a look at Word, most of Word, all of the actions and everything that you can do from the UI and the ribbons, they have a counterpart, or you can easily do them through code programmatically, and that's why, because of COM. So COM sits, most of the COM libraries, they sit in the registry. They're stored in the registry, and it's been told that COM is hard, and that COM is, it's DLL hell. That's why .NET was going to solve the world's problem. But COM, if done properly, it works as expected. However, here, WinRT, what Microsoft has done is that they have revamped and is COM in a different way. And I'm going to walk you through, I'm going to tell you the main reasons for this, right? So with COM, you usually have to be checking for H results, whether it's an S_OK or fail, you have to check for these H results in order to do something else. COMS also means output parameters. You pass like an output parameter, like a reference, because since every method will return an H result, you have to return the return value from that routine or function as an output parameter. And we don't have that in WinRT. COM means add ref and release. Add ref and release, there are two methods which are declared in IUnknown. Every COM object inherits or implements the IUnknown interface. And these guys, you can find them there. And in WinRT, you don't see them. COM also means that you have to initialize the COM engine by calling co-initialize, or once you create instance. In WinRT, you don't do that. You don't have to. COM also means that you have to implement boilerplate interfaces. You have to implement a lot of stuff in order to make things work nicely and play nicely with each other. In WinRT, you don't have to do such a thing. And this one is another thing that WinRT doesn't support. It doesn't support inheritance, right? So WinRT does support inheritance. Excuse me. So is it COM? Really? Well, after I've mentioned and described in walking you through these bullet points, I would say that no, it doesn't feel like COM to me, to be honest. But yeah, under the carpets is all COM code, and I'm gonna walk you through. I'm gonna show you how it works. Cool. So these are two new interfaces. I'm gonna have a bit of water. Please bear with me. There are a couple of new interfaces that we can find in WinRT. The main one is iInspectable. As you can see, there's a link there. The iInspectable interface, every single component, which is a WinRT component, implements iInspectable, right? And as you can see, This is a prototype of that function. Every method has to return a hash result, and it usually returns the output, the return value as an output parameter, as you can see here. Right? So this is the main one. Every library, no matter if you have written that library or component using C# or C++, it implements inspectable, which at the same time inherits or implements IUnknown. So every component which implements this guy here, IUnknown, is a COM object. At the same time, there's another interface, which is the activation factory. And this guy, or this interface, is the one responsible for activating your component. Because the thing is, WinRT applications, they rely on a broker. The broker will perform a lookup in the registry, will find the right class to be activated, and it will read from the metadata and the manifest, and will activate the application, the application for you. But these two interfaces, like I said before, they are the main ones that you're going to find in WinRT, and like I said as well, you don't have to deal with them directly. Cool. So let's move on. Demo time. Okay. Let me share now we're going to start seeing a bit of code. Let me just, got a message. We don't see it. We say, oh yeah. Yep, it's all good. Let me share my desktop once again. Okay. And going to switch to Visual Studio. Okay. What I got here, I built a very primitive calculator using XAML, and it's written in C# and C++. So let me show you what I got here. I got my solution. It's called C# WinRT component. It's got two projects. I got the C# WinRT component, which it contains a primitive calc. The primitive calc for calculator, what it does is pretty straightforward. It returns a float for 4 math operations, whether it's sum, subtract, multiply, or divide. That's simple. As you can see, I don't have any validations or anything whatsoever. All I want to do is just to consume this piece of functionality, this piece of code from my C++ application. Now, everything in WinRT has to be a sealed class, right? That's a requirement. So if you want to build, regardless of the language you choose to use, it has to be sealed. That's a must. Right, so let's go back to, and now I'm gonna walk you through the C++ code, right? What I got here, first of all, is my XAML, and I'm gonna walk you through the XAML a bit later after this section here. All I got here is a text box, the 4 buttons to whether add, subtract, multiply, or divide, the equals, and the clear. XAML is this guy here, which is pretty much based in XML. It's a way to declaratively build user interfaces. I'll walk you through this thing a bit later, but now let's refer to the code.
Hi, Angel.
What I've done.
Hi, it's Carrie.
Yep.
Sorry, we can't see your desktop.
All right. Yeah. Okay.
Sorry about that. Can you try to share the desktop?
Yeah. Let me. Okay. Hang on. Let me just try again. Can you see it now? Thanks for letting me know.
Yeah. No, it's not yet.
Mm-hmm. Now. Can you see it?
No.
It says.
Oh wait, it's loading now.
Oh, okay. Just let me know. So were you able to see my Visual Studio or
no?
Not?
We didn't. No, it was still
All
on
right.
the demo, on the deck rather.
All right. Can you see it now?
It's still loading. Sorry,
No, you're right. No, you're right.
Yeah. Okay. I can see it now.
Can everyone see it now?
I guess yes. Everyone's okay. We're there. Thank you.
No worries at all. It's all good. Okay. So yeah, back to the thing, right? So let me refer to my C# component. Like I said before, I got two projects in my solution. The first one is a calculator, pretty straightforward. It's C# code. All it does is I got 4 operations: sum, subtract, multiply, and divide. Like I mentioned, every component that wants to be exposed in WinRT has to be marked as sealed. Otherwise, it doesn't work, right? That's one of the requirements. And then I was just walking you through the C++ code. I got my user interface, which is SAML based. As you can see, SAML is the next section of this presentation. And let me just go to the C++ code. I got a main page, which is here. This is all native code. What I got here, and like I mentioned to you before, the class has to be marked as sealed, right? And it's quite funny because this might look like C++ CLI, which is the .NET version of C++, but no, this is all native. This doesn't rely on the CLR whatsoever. So what I got here is, well, I got my members here. I'm storing whatever I enter in my calculator as string. This is the hat. This operator is like a pointer or a strong reference. It's a handle, right? What it does is it instructs the WinRT that it instructs the compiler that I'm going to create an instance of an WinRT object. So this is it pretty much. I got my private methods. I got the reset, the button operator click, the equals, the calculate, and the clear. So if I go back to the code, I got this, right? So here is where I create my C++ object. So this is new in C++. Now, similarly to C#, we got the auto keyword in C++, which the compiler will infer the data type of the object when it's initialized. So I got auto operand 1, and this guy, what it does is it converts a string into a float, and that's what I get here. I create my calculator object, and depending on the operation I've selected, I call the corresponding or the right method. So let me just run this very quickly. So I got my calculator here. Let's say 100 plus 25 equals, and the result is 125. This is a new control in WinRT, this message dialog thingy. But let me just refer to the source code so I can show you something very funny. So first of all, let me set a breakpoint here, right? Yeah, that will do. Let's multiply 5 times 5 equals. Okay, and as you can see, right, this is all native, and a good way to show it to you is just by, let me add a quick watch. If I say this, referring to the window, I will be able to see, hang on, this stuff here, which is all native. The VFPTR guy is the virtual table, right? So if I come here, it's all native because I haven't loaded the symbols. I'm unable to step into the theme, but this is all native, right? So what I do here is, if I can inspect the call object, which is the C# thing component I've shown you before, as you can see, it's native code. This is not .NET. This is just native code. So what I got here is based on the selection, I create an instance of the calculator. This is all WinRT. It was written in .NET using C#, but at runtime, it's just a WinRT component. So this is the thing. And then what I do, depending on the operation, I just call the right thing. There's something else I would like to show you. I got this dispatcher guy here, which is the dispatcher for the current thread, right? And I've mentioned at the very beginning of this presentation that everything is synchronously, right? That's why to use the dispatcher is so important, because that will allow the developer not to incur any cross-thread calls. Therefore, you can be doing something in the background and then send it back to the right thread using the dispatcher. This is the new syntax in C++ to create objects. So you call revenue, whatever class, and what I got here, it's a C++ lambda. I am saying, well, capture the window object, and when you do that, you will have access to whatever properties or methods that this guy has, and just create a new instance of the message dialog class, which is, and here is where I'm calling the C# code. But let me show you something very funny. There are a few switches, and I wrote it here because I don't want to forget, right? It's in regards to the tokens. If I come here to the properties of the project, and here I specify that the command line options apply. Let me just rebuild it again. Rebuild. Okay, do you remember when I said to you that this is all COM-based and stuff? Well, what this guy is doing is pretty much what WinRT does. It's that it writes a wrapper around the calls that the component makes to COM, right? So that's why this guy is writing all this information here, in the output window. So it takes quite some time because it's doing it for the first time. Okay, please bear with me and Visual Studio that's compiling all the stuff. And just 1 second, it should be near completion now. For the time being, what I'll do, I'm going to open WordPad so I can show you. Okay, right. So let me search for, what's the guy's name? Please bear with me. Calculate. Yeah, let me search for calculate. Okay, calculate. Okay, here it is. So this is not the one I was looking for. This is not the one I was looking for. Please bear with me for a second. Try. Okay. Try. This is the constructor. Please bear with me. Okay. This can be the one. Come on. Suppose. Okay. Let me see. Yeah, this will do. So as you can see, right? Income you didn't have any meaningful return values. You had to, to get the hash result and then call another function to find out whether there's been an exception or not. With this guy, what WinRT does is it wraps whatever call you make to the component, right? And if there's an exception, WinRT is smart enough to translate that error or that page result into an exception with this. Now, you get to see here ABI. ABI stands for Application Binary Interface, which is the common lingua or of every WinRT component, right? So that's one thing I wanted to show you. The other thing I wanted to show you was in regards to the metadata. So if I come here, I'm going to open Reflector. I love this tool. I just love it. So I'm going to open an assembly. Remember that I mentioned to you, come on, dude. I've mentioned to you that WinRT has borrowed the metadata format from .NET. So what I'll do, demo2, C++, call, debug, demo2, show me all files. Okay. So where's my? Please bear with me for a second. Please bear with me for a second. WinMD, hang on. WinMD. Where's WinMD? Hang on, please bear with me for a second. WinMD. Here it is. So this guy. So WinMD, where's WinMD? Calculator, yeah. So as you can see, this is the assembly that gets generated. This is my class. Okay, just find it. This is the main page, which is this is an enum I had with the subtract, multiply, blah. But as you can see, I got the connect or the I don't see any code. Here it is. Expand methods didn't have any code in it because this whole thing is put together a runtime by the WinRT runtime. That's something I wanted to show you. There's also, let me just close this guy here and refer back to, come on. Oh, come on. There's another switch, which is this guy. If I come here and you want to see the layout of the classes, no, this one here. You see one report, single class layout, and the class name. So you come here and just replace this one. This one is less verbose than the previous one, but this will give you an idea about how your class is compiled. Build. Where's the output window? Go to output. Okay. This is the output is different. The other one shows you the wrapper code around the calls made to come, but this one is a bit more about the layout of the class. So as you can see, at ref and release, they come from IONNOWN, similarly as query interface, but the get runtime class and this guy comes from the inspectable interface I mentioned before. Cool. Let me go back to the Presso. Now we've been able to see that the metadata. Oh no, I got it's all good. We've been able to see that how components written in different languages they can interrupt without any issues, and I also show you or demonstrated to you how the metadata is pretty much the same format as .NET, which is a standard, by the way. And you can use the tools that you got already and the tools that you know, similarly to what I did with Reflector, in order to get to look into that assembly. Cool. XAML. Okay, XAML. So what's XAML? XAML is short for Extensible Application Markup Language, and it's pronounced XAML. It's a markup declarative language used to instantiate .NET WinRT objects. Why did I mention .NET? XAML was introduced in .NET 3.0 back in 2006, I think. And the whole idea was that Microsoft, they wanted to have an alternative to building compelling user interfaces. And they didn't want to use WinForms because WinForms relies on Win32, GDI, and they wanted to build something more appealing, more beautiful, right? So what they did was, well, they came up with this XAML idea about building user interfaces similarly to, when you are building an ASP.NET page, you have your UI aspect of the page in the ASPX page, and it's all about the tags, but at the same time, you had your code behind. So starting from that principle, they came up with XAML. And that's what I'm walking you through or explaining here. So that's why in .NET, like I mentioned before, .NET 3.0 introduced WPF. WPF stands for Windows Presentation Foundation. And it's quite funny because WPF has been used as the foundation for this WinRT XAML support. So XAML, like all XML-based languages, is case sensitive. That means that you can't substitute button lowercase for button uppercase. It can be applied to many different problem domains. Actually, TFS uses heavily, and there's another feature in .NET, which is the Workflow Foundation. Workflow Foundation also uses XAML. It doesn't. They don't use it for rendering or UI purposes, but more for application-specific tasks. And Visual Studio and Microsoft Blend can be used to generate XAML code. So it's declarative UI. Here, what I got here is my XAML code. I got the tag for a button. You got your class. You got your attributes to describe properties, and then you also got your code behind. This is C++ syntax, as you can see. Because of the little hat here, I'm creating a new button. Ref new button equals, this is equivalent to what I got here. So here, it took me just one line of code to express pretty much what I did here with 4 lines of code. So everything, the class hierarchy, everything is an object. And then, this has been, like I said before, borrowed from WPF. You get the dependency objects, the UI element, framework elements, what's the other thing? Control, content control, button base, and button, which is the specific or the realization of the button. So how do you connect the UI to code? Well, XAML generates partial classes declaration, which are paired with hand author code behind. And what you usually do, similarly to what developers use or do with ASP.NET, is that you have your, for instance, you got your event handler here, click, this button underscore click. You do it in the same fashion, the same way. You specify, so for instance, this is C++ code once again. This is an event handler, doesn't return anything. So you specify the class name, the event handler name, which is a method here as has been defined, the click here in XAML, and then you whatever the event handler parameters takes in, and that's it pretty much. So the controls, they are the core of the UI framework. They've been designed for full immersive applications. Even though the controls might look similar and behave similar to WPF, they are not the same controls. They are different because we're talking about 2 different technologies here by the fact that WPF runs on top of the CLR and this runs on top of WinRT, right? It's all based on templates. So, and here, this slide shows you a bit of some of the controls that comes in box of the of WinRT, and all of these controls, they can be leveraged and reused from your applications. And you can even extend it, or you can also change the way they look and the way they behave by using templates or just inheritance. So you get your buttons here, your hyperlink, your grid, password control, list view, semantic zoom, etc. And there are quite a few. By the time I put together this slide here, that was when Windows 8 was on pre-release state, and then, but with the latest release of the operating system, Microsoft has included much more controls. And I can I'll just walk you through the SAML before, but I guess I'm running out of time, so I'm not going to enter into the details of the SAML. So let me just cover the last part of the session, which is async and await, right? So please bear with me for a second. I'm going to have a bit of water here. Just one sec. Okay. So async and await. This is, as you've been able to see, I've been mixing the code in the presso for between C# and C++. However, in everything that I've covered so far applies to both. However, the async and await are specific to C# and .NET. Cool. So, async in a nutshell. What is synchronous? What is asynchronous? So, synchronous is that you kick off something and let's suppose a task, and you'll have to wait for the task to complete before getting any results back to the caller. Good example, download string. I kick off this guy, it will return a string, but the thing is, this is depending on the environment. Let's suppose that you're downloading feeds from a website. If the website is down, it will time out, and the UI thread might become unresponsive. So that's the drawback about synchronous programming. However, developers, they tend to think that they're in control, much control than in this way or of synchronously, but that's something that we could debate all day long, right? So that's synchronous. Kick off this, do this. But I'll have to wait till you complete your task so I can get the results back. It's synchronous. Well, it returns now, but once the task that has been kicked off completes, I get the result with a callback or a delegate, right? So this is another good example. Download string async. I do stuff, and I pass in a delegate, or in this case, I'm using an action delegate, which returns a string, and that's the callback that is going to be returned to the caller. From all of the benefits I can think of asynchrony, I would say two. So I would mention two. That's what I meant. I would say UI responsiveness. The whole thing is it frees the UI thread for interaction. Sometimes this is something which developers, I'm not going to generalize here, but some developers, they forget to do when they kick off a long-running process. Instead of kicking off that process on a separate thread and freeing up the main UI thread, they do it from the thing, from the main thread. That's why the application was blank if it was waiting for inputs or something. But the thing is, it's being bad implementation. It's not the operating system. It's not Windows that just froze. It's that the implementation is not right. So multi-threading development is not easy, but it's not also hard. Similarly to COM, we developers, we have to be aware about how to do it in a nice way. And if you do it nice, if you do it right, you don't have to have any concerns. Back to the slide. So the other benefit is that server scalability. Let's suppose that you have this thing running on a server or as a Windows service, or as a a console application maybe. When you do things in a synchronous way or fashion, what happens is you can leverage the existing hardware. Let's put it this way. It doesn't take the same amount of time to do one task in serial, right? And wait for something to happen or to complete, rather than splitting the task into multiple threads. So asynchrony, in a nutshell, is pretty much, this is what I brought this slide. The purpose is to remind you guys that Windows 8 is asynchronous all the way, right? There's no such a thing as kick this off, come back to me straight away. No, it's all asynchronous, right? So let's move on here. A good example of synchronous versus asynchronous. So the first image, the first graph here, is all synchronous. You got your bar equals download data that talks to a web server, and then you call process data using as input or parameter what you get from download data. However, you got a stop sign here. You won't be able to call process data until download data has completed, right? In the asynchronous world, you got download data async, do your stuff, and then you get a lambda, which calls the process data. So you're not blocking, you're not waiting for something to complete. This follows the Hollywood principle. Don't call me, we'll call you, right? So let's move on here. And we got a demo time. There are a few other things that I would like to cover, but so for instance, I haven't covered anything around data binding or any design patterns like MVVM or how to customize styles, because what I'm giving you guys is just sparkling that planting that seed of curiosity. After this session, my expectations would be that, okay, well, if I don't have Visual Studio, I'm going to get Visual Studio, and I'm going to start playing with this technology, and then if I have any questions, I'm going to reach out to any other MVPs, or I'm going to send Angel an email, and it's pretty much, the purpose of this session is to get the ball rolling. There are some areas that I've been unable to cover due to time constraints and limitations, but the idea is to get you started so you can, start your journey as a Windows 8 developer. Okay, so I'm going to open close solution. I don't need this guy here. I'm going to show you something else. Right, so recent projects and solutions. What I've written here is a fit reader. This is all C#. I'm not using any C++ for this example. Very quickly, I'm gonna walk you through what I got here in my XAML. I got the fit URI, which is text blocks here. This is my XAML. I'm downloading. I'll download the fit from this URL. I can change it to any other URL. And then I got a list view here, which will be used to display the items I've downloaded from the website. So if I go back to the code behind, it's pretty straightforward what I got. I got just one handler here, right, which is the button click. As you can see, I'm marking this method to be asynchronous. So that's the first thing that you want to do. If you want to have a method that will be considered, or you want the CLR to handle or manage it as asynchronous, you have to mark it with this keyword. That applies to C# only. And then here what I do is, this is something which comes with WinRT. Now you can have a syndication client if you want to pull stuff from the internet. I create, if the URL is not null or empty, I create a new syndication client. And the next step, what I do is, well, I create a new URI and I pass to the client the URI I specified. So as you can see here, I got the await. So the way this works is like this, right? So you mark your method with async because that will potentially be waiting between quotation marks because it doesn't wait, right? It will call something asynchronously. And then whatever method you're waiting the response from, you prefix it with await, right? It's as simple as that. And then once this guy has finished, the code will resume from this line onwards. What I got here is, well, connect to that feed URL, give me the items, retrieve the items, and then just clear the list and just populate the list once again. One thing I would like to bring to your attention, for each is no longer, it doesn't exist in WinRT because for each might break or might cause an issue. So Microsoft deprecated the for each method in WinRT. However, what I've done, I've created a link an extension method which will take an enumerable, in this case a list, and will take a lambda, similarly to mimic or to replicate the functionality of the for each we all know. So let's just run this guy. Here it is, right? So I'm going to get fits. As you can see, I can click here, here. The UI is doing stuff. And boom, that's it. So here it is. This is what I was able to pull from this website. So let me just go there, Control C, and open it here. That's what I just pulled from the internet, right? So let's go back to the thing. So very quickly, I'm going to set a breakpoint here, and then call it again. So I should have called it before, because I wanted to show you some of the cool things in Visual Studio, which is the parallel stacks and stuff. Okay. Let me see if I can get to it. No. I have to break right away. Hang on. Let me just move it here. Okay, let me just stop it. Run it. Let me see if I can get to it. Come here very quickly. Where is it? Right. Okay, 10. Come here. Come here. No, I couldn't get to this. It just occurs too quickly. But anyways, yeah, this is one of the things which allows you to get to see the stuff running, which is awesome. Okay, so now we know that, you know, what's the purpose of the use or the use for the async and await keywords, right? So let's go back to the Presso for a second. Okay, okay, hang on. Yeah, here it is. Nice. Cool. And that was the demo for the async await in C#. And yeah, Q&A. Is there any questions or anything that you would like to ask? Questions? Questions?
It does look like people are typing. Oh, you're on the chat. Okay.
Cool. Thanks, Edwin. No worries at all. More than happy to help. So yeah, well, thanks for joining us today. I hope that that this session was of use for you and that you found it entertaining. And thanks for joining us, and I hope that you have a great weekend ahead. Thanks very much. Thanks.